Drop water on a heated surface, and it slowly boils and evaporates. Heat up the surface some more, and the water sizzles away instantaneously. Keep increasing the temperature, and suddenly the droplets coalesce and float above the surface. This is the Leidenfrost effect.
Here, the bottom part of the water droplet vaporizes immediately on contact with the hot pan. The resulting gas suspends the rest of the water droplet just above it, preventing any further direct contact between the liquid water and the hot pan. As steam has much poorer thermal conductivity than the metal pan, further heat transfer between the pan and the droplet is slowed down dramatically. This also results in the drop being able to skid around the pan on the layer of gas just under it.
So, we try to replicate the setup that is required to demonstrate the Leidenfrost effect. Here, we heated the pan to about 200 degrees centigrade. The condition is that the temperature of the pan should be way higher than the boiling point of water. Now, as you can see, as soon as the water droplets touch the pan, they do not evaporate instantly. Instead, they seem to hover over the pan. As we tilt the pan, the water droplets also move in the direction of tilt.
One human hand in molten metal. Ho, 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 ho. No lie. The Leidenfrost effect is no myth. It protected us.
The inverse Leidenfrost effect was first described in 1969 and involves a hot object such as a droplet levitating above a cold liquid. In this case, heat from the droplet causes some of the cold liquid to evaporate, creating the repulsive cushion of vapor. Here we levitate a droplet on a bath of liquid nitrogen. It's inverse because the droplet is not actually creating the vapor, it's the bath beneath, it's the liquid nitrogen that's creating the vapor. The moving droplet could potentially be used to cool an overheating microchip inside of a computer.
Notice the waves generated in the middle of the beaker? These little waves lead to an asymmetry underneath the droplet, where one side is higher than the other. More nitrogen gas escapes out this side. Now you might think this would drive the droplet in the opposite direction, but it doesn't. The gas actually drags the droplet along with it, kind of like how wind over your windshield pushes raindrops along.
The paper reported a way to move beads of water across a heated surface covered with stair-like ridges. As the droplet encountered a ridge, the flow of vapor beneath it pulled it up and over, even when the surface was on a slight incline.
You could imagine making something where you could at the same time freeze your cells or chemicals and then move them along without generating any contaminations because you are basically not touching them.
If you arrange the blocks in the right directions and you put the walls in the right places, it will work.
Behold the Leidenfrost maze.